If you are an entrepreneur or an individual representing a company and you intend to offer an AI model to European users, one of your first legal tasks would be to learn if your model qualifies as a general-purpose AI model. This is necessary because the EU AI Act regulates the offering of those models and you'll be facing compliance work. The general-purpose AI model definition covers the four elements: existence of an AI model, significant generality, capability to perform a wide range of distinct tasks, and capability to be integrated into downstream systems or applications. Alright, let us first examine what the AI model means. The Act doesn't directly define it, but I have researched the two different definitions that we can rely on. International Organization for Standardization, so-called ISO, defines an AI model as a physical, mathematical, or otherwise logical representation of a system, entity, phenomenon, process, or data. On the other hand, according to the National Institute of Standards and Technology, so-called NIST, an AI model is a component of an information system that implements AI technology and uses computational, statistical, or machine learning techniques to produce outputs from a given set of inputs. These two definitions tell us that an AI model is not an AI system and can only be its component. AI models, as a rule, are trained on a large amount of data and also use various types of AI techniques. Yet, no matter how strong and sophisticated the model is, it still exists in its initial form and can't be used by end users directly. For that, you need extra components, additional features, such as an user interface. We can compare this initial model condition to the newly released unintegrated algorithm or statistical model. An AI model can also be released through libraries, application programming interfaces, so-called APIs, direct downloads, or physical copies, but none of these releases make the AI model an AI system. It requires adding extra features. Let us now discuss significant generality, one of the key elements the model must meet to be considered a general-purpose AI model. The Act offers several requirements for significant generality, but they are too broad and non-specific. Recital 98 of the AI Act says that models with at least billion parameters and trained with a large amount of data using self-supervision at scale should be considered to display significant generality. So the key factors include the number of parameters and the amount of training data. Given the very broad nature of this requirement, the EU Commission in its guidelines came up with a more elaborate measurement for significant generality, which is the amount of computational resources used to train the model, otherwise called training compute. AI model training requires a large number of floating point operations, FLOPs. The EU Commission takes FLOP as a training compute measurement unit and estimates the training compute according to the number of performed FLOPs, where a higher number of FLOPs indicates higher training compute. The Act defines a floating point operation as any mathematical operation or assignment involving floating point numbers, where floating point represents a numbering format used to handle large, complicated numbers. Introducing training compute as the only metric of a model's capabilities and a single threshold saves the time that would be needed to assess the other two distinct thresholds, the model size and training data size. So, what is the training compute threshold that an AI model should achieve to become a general-purpose AI model? It needs to perform FLOPs at least greater than 10 raised to the 23rd power. The EU Commission settled on this one metric to simplify estimation and use one instead of the two broader thresholds, parameters and training data. Indeed, this threshold represents only an approximate amount that is typically used to train a model with 1 billion parameters. In truth, such models may be trained with varying amounts of compute, yet 10 raised to the 23rd power FLOPs is typical for models trained on large amounts of data. In particular, mainstream AI models with approximately 1 billion parameters as a rule need this amount of training compute. It's not easy to estimate the actual training compute, and many providers shall make calculations in advance before model training is complete. Therefore, the providers are free to select the most convenient method to estimate the relevant amount of training compute. Like they may select tracking graphics processing unit GPU usage, that is called hardware-based approach, or direct estimation of operations based on the relevant model's architecture, that is called architecture-based approach. You can consult the EU Commission guidelines for a more detailed explanation of each method. Providers need to document their estimations, which shall cover the assumptions made, the method of estimation, and the associated uncertainties. They are also supposed to make estimations in their best judgment, which can be within the error margin of 30% of the reported estimate. But significant generality is not measured strictly by the amount of training compute. There can be other metrics such as model's capability to generate language in a textual or audio form or transfer text in different formats, including images and videos. As 10 raised to the 23rd power flops is not a rigid threshold, a model with less training compute may still display a significant generality if it can output language or has other exceptional features and is versatile enough. This can be true with other non-linguistic AIs, which require less training compute but still display significant generality because of the way they operate. Finally, the model that meets the flop threshold and can competently generate complex text may display significant generality with high likelihood. I think that the good illustrative example is Google's Gemma 3. It is a 1 billion parameter text-only version, and it can support multiple languages, analyze text, reason and solve moderately complex math and coding problems, all within the same module. Although its training compute can be slightly less than the established flop threshold, it may still satisfy all other criteria and qualify as a general-purpose AI model for the Act's purposes. The next important element is a model's capability to competently perform a wide range of distinct tasks. Interestingly, the language generation is relevant for this element too. The model that can generate text or speech is presumed to be advanced and diverse, as it can store knowledge, communicate, and reason. Therefore, unlike other less complex models, language models are typically more attuned with a wider range of tasks. The same applies to the large generative AI models that generate other types of content along with language. There are models with a narrower range of capabilities and a lesser scope of application, which can only generate images or videos. Yet, they may still qualify as general-purpose AI models if they have multiple features and can flexibly generate content. In sum, to qualify as a general-purpose AI model, the model shall display significant generality and shall be able to perform a wide range of distinct tasks. The best candidate is a multi-profile, large generative model that meets the 10 raised to the 23rd power flop training compute threshold. Yet these requirements are more exemplary rather than strict. Other multi-profile models may also qualify as general-purpose AI models if they are sufficiently general and versatile. Alright, the final element is the capability to be integrated into downstream systems or applications. Standalone, a general-purpose AI model is not an AI system. As I have already explained, the AI system definition has 7 elements, out of which 6 are mandatory. The non-integrated general-purpose AI model may fail several of them, especially the capability to influence physical or virtual environments. The general-purpose AI model may form a part of an AI system, and for that it requires the addition of extra components, such as a user interface. I should also mention that the provider who integrates its own general-purpose AI model into the AI system will face the EU AI Act provisions for both the model and the system. To conclude, the general-purpose AI model, first and foremost, is an AI model trained on a large amounts of data, which can leverage AI technology to do complex computing and generate an output. Its status as a general-purpose AI model depends on its multi-profile, general character, and the amount of training compute. The requirements can be reduced to 3 main criteria: complexity, size, and versatility. A general-purpose AI model standalone is not an AI system and requires integration into another system, or adding extra components to become one.